Hello learners, welcome back to the course on construction methodology. So in today's class, we are going to understand what is starter for the column, how we are going to do the marking of it, and how we are going to place the concrete for the starter. Then we'll try to see what are the different dimensions of the starter frame that is available and how we are going to relate that with the drawings. Then we'll try to understand how a starter concrete is placed, and then we'll try to understand uh, how it looks practically at the site, and we'll try to understand what is cover blocks and what are the importance of providing a cover block for the column. So we'll start one by one. So once we have done the footing, this was our PCC, this was our PCC, this was a PCC, and this is the footing we are done. So once this is done, the next task is to do the shuttering for this column, and then we have to place the concrete into this. So before doing that, there's something called starter. You call it, sometimes people call this as column kicker. It's one and the same. We'll call it by a name of starter, that is starter concrete. So what we are going to do, we'll place something called a column starter, and we'll try to see how it looks. So you can see it here, right? See there's a small concrete placed here, say about 75 to 70, 50 to 75 mm. And once you place this column starter, over that we are going to place this column box, that is column shuttering, because if you don't place this column starter, this column box cannot be kept straight, I mean exactly over that. So this will not have enough strength to hold it. So because of that reason, what we are going to do, we are going to give a small base for this. We are going to give a small base for this column box, so that it will be aligned in a position and it doesn't move here and there. So we'll try to see that. See, look at it. Look at this. So again, they have done a footing here, and this is a column starter. So in this case, the what you call the depth of this column starter is somewhere like 150 or 200 mm. Again, it depends what is the size of the column. So based on the size of the column, we are going to put this column starter. So this is how it looks. So this is like 150 mm, and say the column size is like 200 by 900 mm. So based on that, what they have done, they have put this column starter. Because if you don't provide this, you cannot keep your column shuttering directly over this. So your column shuttering will not have enough, strength to, it will not have enough stability to stand in its position unless and until you don't give it a proper base. So in order to give a proper base for the column shuttering, we are providing this column starter. So we'll try to see this. The aim of the starter for the column is to support the shuttering. That's the first thing what I explained you. If starter is not prepared, then aligning of column shuttering becomes difficult. Okay. So if you're not providing the column starter, then you cannot keep the column boxes. So because of that reason, what we are going to do, we are going to place the starter concrete. So how we are going to place it, we'll try to see it here. So this is called a starter frame. It is made up of steel frame here. Sometimes local contractors, what they do is they can make use of the wood, and with the help of the wood they are going to make this starter. So the starter frame is prepared at the site, either of wooden or of steel frames. So this is a steel one, and so this is how a starter frame looks, and the size of the starter frame is equal to the size of the column. So what do you mean by this? For example, say a column is like C1, the name of the column is C1, and its size is like 300 mm. So this is 300 mm, and the other side is 600 mm. So whatever is the size of the column, that will be the size of the starter frame. So from where we are going to get all these dimensions, again you have to refer the drawings in the column layout. So there you are going to get, for say this is a column, and the name of this column is C1, and the dimension of this column is like 300 mm by 600 mm. So this starter frame is prepared based on this dimension, and it is kept inside the column reinforcement. So the starter frame is then filled with a concrete of say 50 to 100 mm thickness and allowed to set for a day. So this 50 to 100 mm is not a constant, it depends. But most of the cases, what happens is we try to keep it between 50 to 100 mm. Say sometimes 50 mm we are going to pour the concrete, or sometimes 75 mm thickness also we are going to keep. Or sometimes if it is a bigger column, then we'll try to keep 100 or 150 mm. So we'll try to see that again. So this is how it looks, and this is a starter frame what we have prepared. Okay, and we are going to keep this, and over that we are going to pour the concrete. So if it is a big column, say we are going to keep the thickness around 100 mm or say 150 mm. Usually 100 mm is enough. So we'll try to keep 100 mm, and we are going to cast this concrete, that is a column starter. So we'll try to see it in a more detailed way. So this is how a starter frame looks. So this is another starter frame what we have kept here. And see, once you give a starter frame, we are going to pour the concrete into this. We are going to pour the concrete into this. And after a day, say now it's like 11:30 today, and tomorrow early morning around around 10 o'clock you enter the site. You can remove this. It's not of great importance. Only to give a base to the shuttering we are going to put this, so this doesn't carry any load and all. So you can see here, right? See, look at this, see, this is called as construction joint. This is called as construction joint. What actually happens, so you're placing the starter concrete today, and the column concreting will be done one day later. So because of that, what will happen if tomorrow you do the concreting of the column, that will be a new concrete, right? It's a fresh concrete, whereas this concrete is already old one. So in order to have a bond between the new concrete and the old concrete, we try to keep something like this, something like, we are trying to make the surface a rough. So how you can make this as rough? You don't provide any concrete into this. So this will become a rough surface, and the new concrete will be a new one. So that will be smooth in nature, right? So because of that, in order to get a good friction, in order to get a good bond, we try to keep this. So it's not mandatory all the time that you have to do like this. So some contractor try to keep these stone chips over this, so that the stone chips will be like, it's hard in nature. I mean, it's rough in nature, and the concrete that you're going to pour into this concrete is a new concrete. So there will be a bond between the new concrete and the old concrete. So this is called as construction joint. So here they are not provided. So it's not mandatory. Again, depends on the mindset of the contractor. It doesn't play any a technical role in that. So it's always good if you provide, it's well and good. If you don't provide, try to keep for a few stone chips here, the coarse aggregate here, so that it will become a rough surface. So this is another column starter what they have provided, and then they have poured in the concrete into this. So these are the wooden starter frame. These are the wooden starter frame. So this is the starter concrete what we have provided. Few engineers call this as kicker concrete. Kicker concrete. It's one and the same. So this is a starter concrete. So this thickness can be 50 to 100 mm. Sometimes we try to keep 75 mm also. Some engineers go for 100 mm. So there is no hard and fast rule that you have to keep 50, 75, 100. You can go based on your requirement. So this is how these are the different dimensions of the starter frame that is available, right? So when you work in a big structure, you don't have a single column, right? You'll have a column of C1, you have a column of C2, you have a column of C3, you have a column of C4. Look at this. This particular building has column up to C12. Okay. So for example, imagine you want to prepare a starter frame for C1 column. Very good. So what is the size of the column? The size of the column is 600 by 300 mm. So I'll see a starter frame of 600 by 300 mm. So I'm going to carry this starter frame and place into that concrete, and over this I'm going to place the concrete. So this will become a starter concrete. Now say you want to prepare for C10 column. So C10 column, again it is 600 mm by 200 mm. So this is 600 mm and this is 200 mm. So I'll make use of this starter frame. In the same way, I'll try to go with this C11 column. It is 200 by 450. So I have a 200 here and I have a 450 here. So based on that, this starter frames will be kept ready. So if you don't have the steel one, you can make use of the wooden and you can prepare it at the site. So I'll play a video so that you'll try to, you'll get an idea how we are going to keep the starter frame. So these guys are already keeping the starter frame here, and they're trying to adjust the starter frame. So this is how our starter frame looks. They already placed a starter frame and they're trying. So this is how it looks. So this is the starter frame again. So now we are going to pour the concrete into this, because since it is a very a big column and there's a lot of longitudinal reinforcement. So we are making use of the vibrator so that this concrete will reach each and every of the uh, uh, place, right? You cannot make use of your hand and do this. So with the help of the vibrator, we are going to spread this concrete uniformly. So this is how it is. You have placed a concrete. Now with the help of a vibrator, we have put in the starter concrete. So we'll try to allow it for a day. For example, I'm pouring it right now. So I'll wait for a day, like say at least 16, 17 hours I'll wait. And next day early morning, like if I come to site around 10 or 10:30 in the morning, I'll try to remove this. So we'll get a solid starter concrete. Yeah, that's it. So we'll go ahead again. So this is how it is. So I'll try to play another video. So what is the main idea of providing a starter concrete? So this is my starter concrete. These are the longitudinal reinforcement what I've provided. And then what I'm going to do, I'm going to make use of this shuttering boards, the steel one. So this will act like a base for that, right? So this board will have some fixity or say some rigidity at the bottom so that you can keep it straight. Otherwise, what will happen if you try to adjust here, this may try to go inside. So in order to get a vertical surface, or in order to get a straight level, we are trying to make use of this starter concrete. So this is how we place. So this is a column box. So this is how it looks. You placed a concrete, and over that, see, I'll go back to this again. So the one I was speaking. So this is like a like I mentioned the construction joints, right? So look at this. These guys have made it bit. I'll play it again. These guys are placed here stone chips so that it will act as a rough surface, because the concrete is already poured into this. And next day when we start to pour the concrete into this column, this will be old surface, the new concrete will be, and then fresh concrete will be a new one. So because of that, there will be a good bond between this. So that is why we keep the stone chips. If you don't want to keep the stone chips, not an issue, you can do a very level surface to this, and you can place the new concrete. So there is no hard and fast rule that you have to always, keep the stone chips here. Yeah. So this is how it looks. And so this is the base for the column shuttering, that is called as column starter. And if you don't use if you're not interested to make use of the wooden one, you can go for the steel box column shuttering. This is a steel box. So you have two pieces here. This is one piece, and this is the other piece. This is one piece, and this is the other piece. Then you have to, with the help of the nut and the bolt, we are going to tighten this, and this is finally how it looks. So always when you do the concreting work, shuttering oil to be applied before placing this box, right? Because if you don't apply the shuttering oil to this and you place the concrete, and you keep and you place the shuttering box and you try to pour the concrete into this, what will happen the next time when you try to remove this column, the column is not going to come out easily. I mean, the shuttering the column shuttering is not going to come out easily, because what will happen, there will be affinity between the shuttering and the concrete. So in order to avoid that, because I want this shuttering column shuttering to be removed, so I'll apply a oil to this. So this oil will not have that much affinity. I mean, it will not allow the concrete and the shuttering plate to get what you glued to each other. So it will act like a what you call a divider to that. So what we try to do, we'll apply the oil to that. So next day when I need to remove this shuttering, it will come out easily. And even this, you can be reuse this shuttering again. So say like a column's dimension is 200 by 600. So this is finally how you get, if the column, like if you want to prepare a 200 by 600 column, so this is 200 and this is 600 So finally this is how you're going to get. So if it is some other column like 400 by 400, then you will try to make use of the different box, and the 400 by 400 is placed on that particular column. So actually what happens, so whatever I was speaking, this is actually in a big projects. Okay. And imagine you're working for a small project, like if you're constructing a house and all. So the local contractor doesn't believe in all these things. What they do is they'll call these laborers and they'll ask to do the marking here, and they're not going to place the starter. They'll directly keep this column box over this. So that is also okay, because since it is a small project, if your column gets what you call tilted, or say if your column shuttering gets tilted here and there, it doesn't make a difference. But in big projects, you'll have a PMC and all, they're not going to allow you unless and until you put a starter concrete. So if it is a small project, what these guys do, they mark the column line here. This is a column dimension. Say if it is 200 by 600, they already done the marking here, and this column box they're going to lift directly. They lift it and they're going to place it over this. So that is also right way. Only the thing is you should make sure it is in plumb. That is, it is very, I mean, it is vertical in nature, and you can go ahead with that. But when you work for big projects and all, it's not a right way to do. You have to always pour a starter concrete, and then you have to keep this column shuttering. So this is how it looks. This is a bigger column, say like this is 200 by 900 mm, and this is how they have kept the column started. This is made up of wooden frame. Again 7500 100 mm. Again it depends. So this is how it looks finally, right? So yeah. So you can see here, right? So like see, this is 200 mm and this is 600 mm. Now, these rebars, whatever longitudinal reinforcement bar, what you can see here, they're not exposed, right? There's some gap between this bar and the outer surface of the concrete. Same thing is here. There's some gap between this stirrup outside line, this stirrup, this lateral ties to the outer surface of the concrete. So what is the reason for this? So this is called as cover. Like I mentioned in column, we are going to provide 40 mm as a cover. So this is 40 mm from here, from the outer surface to the column reinforcement, it is 40 mm. So what is the idea behind this? Because as I mentioned, in column we are going to give cover from fire resistance point of view. So imagine tomorrow your building is caught up with the fire. So maybe due to some short circuiting, your building is caught up with the fire. So once the building is caught up with the fire, so what will happen? The fire will be first attacked to this concrete, right? So this particular column will be attacked to that, will be exposed to that fire, and this concrete will start to get damaged. So this steel is inside this column. This steel is inside this column. So the steel will have carbon content in it, carbon content in it. So what will happen? And we know that the carbon is a good conductor of heat. So moment the carbon catches the fire, it's going to deteriorate and it's going to fail. So because of that reason, what we are going to do, we are going to give this cover. So this much amount of cover, because this much amount, this 40 mm bar we are taking inside. From here we are taking 40 mm inside. Even if tomorrow your column catches up with fire, it will have enough time. It will have enough time. It will have enough time till the fire goes inside and tries to damage this particular rebar. So that is the main reason of giving this cover to the column. So see, I'll try to put it in a very better way. So all of you know that why the 9/11 tower field has the heat of fire intensified, the joints on the most severely burned floors give way, causing the perimeter wall columns to go outwards and floors above them to fall, right? So the three buildings in the World Trade Center collapsed due to fire-induced structure failure. Because what actually happened is because of the same reason. And the fire started to damage the column, and once the all the concrete got damaged, the next was only this person, the steel was there. And because this guy had the steel has a carbon content in it, the moment the carbon catches the fire, it is going to deteriorate faster and faster, and finally your building is going to get collapsed. So that is the main reason of providing a cover blocks in the column. So this is 75 mm again column starter, and this is the starter column. And from where I'm saying this is for table, this is from a cloth book, that is table 68, 16A of IS 456 2000. Look at this, fire resistance, and this is H stand for hours. For how many hours your fire can be resisted by that particular concrete. For example, if your fire is like for half an hour, if fire is for 1 hour, if fire is for 1.5 hours, up to 4 hours, then the column you have to provide 40 mm of cover. So if you're providing a column cover up to 40 mm, that is well and good. This is we get all these things from the clause books, from the code books, and from this clause of 21.4. So next is cover block. The importance of providing a cover block. See, all these are the cover blocks. These are the cover blocks. All these are the cover blocks. And you can see the column starter here, and you have raised a column, and these guys have provided a cover block to this. So what is the cover blocks? How much you have to provide? 40 mm in case of column. And sometimes you can provide 25 mm. So what is the reason of providing this 25 mm? We'll try to see. There's another clause mentioned in IS 456, that is 26.4. However, for a longitudinal reinforcing bar in a column, nominal cover shall in any case not be less than 40 mm. That we know that, right? In 40 mm is minimum what we have to provide, or less than the diameter of the bar. In case of columns of minimum dimension of 200 mm, what is trying to tell is, imagine you have a column of 200 mm by 200 mm. Length is also 200 mm, and say it is like 150 by 150 column. 150 by 150 is a column. It's a 6-inch column. Okay. So if imagine you have a column of 150 mm by 150 mm, and the bar that you use, these are longitudinal bars. The vertical bars, what you can see, those are called as longitudinal bar. And if they're 12 mm in diameter, whose reinforcing bars do not exceed 12 mm, right? So imagine you have a column of 150 mm by 150, and the rebar, that is the reinforcement bar, that is a longitudinal reinforcement bar, what you provide is 12 mm. In that case, a nominal cover of 25 mm may be used. So written 25. Now you have to try to understand this in a more better way. What is written here? 25 mm may be used. So it doesn't say that must be used. He is telling may be used. So it's up to you to use 25 mm or 40 mm. So the normal practice is we always try to go with 40 mm only. If it is a 150 by 150 column, in that case, you can reduce the cover block and you can give 25 mm. But again, the code says that may be used. It's not saying must be used. May be used. It's up to you to decide. And footings is already mentioned. We know that for footings, minimum cover shall be 50 mm. So these are the cover blocks. These are the cover blocks. So this is 40 mm, and this should be for all these things. So this cover blocks is available in the market of 40 mm. This is how we keep cover blocks for the column. So what is the main reason of providing this cover block? See, now look at this column. I'll try to explain it. See, look at this column, right? So from here we are getting 40 mm. This is a column. I mean, this is a column shuttering they have done. And once you place the column, this bar will go inside the concrete. So here you are getting 40 mm, 40 mm, 40 mm we're getting. But as you go upward, what is happening? Here you are not giving any cover, right? Because since it's laterally unrestrained, so the height of the column is more, so it will try to tilt. So this column has, this reinforcement bar has tilted this way. So as you go upward, what is happening? Here it is fine. Up to here you are getting 40 mm of cover. But if you're going upward from here, look at this. There is no cover at all, right? This bar is exposed to the, like if you place a concrete and if you remove the shuttering, it will be exposed to the atmosphere. So what you have to do, you have to provide this cover blocks here. You have to tie one cover block here, so that what will happen, this column will be aligned straight, and you are going to get 40 mm throughout. From here also you will get 40 mm, the same 40 mm. The same thing is happening here. Here you are getting 40 mm. By the time you reach up, it's more than 40 mm, right? So up to here it is fine, 40 mm. But if you go here, it's more than 40 mm, like 40, 60. I guess this has gone up to 60, 70 mm. So that is not possible. So what you have to do in order to bring this straight, since it has tilted, so it has gone this way. It has tilted this way. So you have to provide a cover block here, and finally this is how your column looks. So this is how it is, 40 mm. This is 40 mm. This is 40 mm either side. So on all the sides, 40 mm, 40 mm, 40 mm, 40 mm, right? So this is how your cover block will help you. So even if your column catches up with the fire, the outer surface of the concrete will be exposed to the fire first, and then once all this is damaged, this concrete surface is damaged, then your rebar will be exposed. So you guys will be having enough time to come out of the structure, to come out of the building, or even if it catches the fire, this rebar will not be exposed, so that the building will not collapse suddenly. It's going to take time, and then it's going to collapse. So that is the main intention of giving this cover block. See, this is how it looks. So this is fine. This is fine. Look at this. Here you are getting cover block. Here you are getting 40 mm, 40 mm. But again, if you go up, you are getting more than 40 mm. And look at this. You are getting 40 up to here. But if you go almost to the top, what has happened? This stirrup, I mean, this lateral tie is touching this shuttering. Again, you have to place a cover block here, and you have to place another cover block here. So then what will happen? This entire column will get aligned, and it will stand in a position, so that this gap what you are getting extra. So up to here it is 40 mm, that is fine. But if you're going again up, so this gap is more, this gap is again more. So this column has to be pushed to this side. So that push can happen only with the help of a cover block. We'll try to tie one or two cover blocks here. One we have to tie here. The second cover block we have to tie it here, so that you'll get a 40 mm of cover throughout. And that is how we have to do. So we'll try to play a video. So we'll try to understand it. So this is a starter concrete we have provided, and this guy is keeping the column shuttering. This is how we are trying to keep. So I brought in the another see, column shuttering. So this is like 600 mm, and this one is like 200 mm. So that, the size of this shuttering plate will be kept ready with the contractor. So based on that, he's going to tie this. He's going to make this column shuttering. So this will act like a, base to this shuttering, so that it will not try to go inside and out. It will not try to move here and there. So it will stand in its position. Yeah. Yeah, finally, this is how your column looks. This is how your column steel box looks. We have done a footing, so this is a combined footing. Forget about that. So this is how you have kept your column shuttering, and you are given this support, so that even what will happen while doing the concreting, this column should not tilt here and there. So these guys have given the support to this column, and finally, this is how the column steel box looks. So well, we'll see you back in next video. Thank you.